Hey, you guys, this is Mrs. Newsome. So today we're going to tackle lesson 5-7, and it's an asynchronous day, but I wanted to keep us kind of practicing surface area. So you have a video lesson today to kind of walk you through the journal pages. So in your math journal right now, I am on page 243. Cool thing about the video is you can stop if I'm going too fast. You can watch it again if you didn't understand something. So just use the video, go slow. And I'm going to kind of walk you through page 243 and 244, which is your journal work for today. So let's take a look at the math message. I couldn't skip this question because of the Rubik's Cube, especially for Reed because he's been kind of, improving his time and working on that. So I thought this was cool that we had a Rubik's Cube question. So it says the Rubik's Cube is a puzzle that starts with all of the colors mixed up. The goal is to realign the cube so that each face is all one color. The world's largest Rubik's Cube was made for the Knoxville, Tennessee World's Fair of 1982. Each edge of the largest Rubik's Cube is 3 meters long. So we're imagining this right here, that this is 3 meters, this is 3 meters, and what's the other dimension? So that would be this is 3 meters. So it's a 3 by 3 by 3 meter cube. Now think about what a meter stick looks like. That's a really big Rubik's Cube, right? So the question says, for the world's largest Rubik's Cube, approximately how many square meters will be painted if the entire cube is painted? So this is a surface area question, and so we're trying to find the surface area of this world's largest Rubik's Cube. Now the cool thing about a cube is if we know one face, then we can just times it by 6, because on a cube, all 6 faces are equal. So here we have a 3 by 3. So this red face here has an area of, let's see if I can write it, 9 meters squared, right? And so that means all 6 faces are going to have an area of 9 meters squared. So 6 times 9 equals 54. So that entire cube would have an area of 54 meters squared. It's pretty huge Rubik's Cube, right? Yeah. All right. So we are practicing surface area today. The rest of them are not cubes, so they're going to be a little bit trickier than that one. And we're going to practice drawing our nets again today. You will have to draw nets on your quiz coming in on Friday. So this is really good practice drawing something. And today what we have are not rectangular prisms. So this one is a triangular prism. And you can see that the ends are triangles, but then we have 3 rectangles that kind of connect those triangles at the end. So this says Antoine's favorite mechanical pencil lead comes in a container shaped like a triangular prism. The base of each triangular prism is about 2 centimeters long. So the triangular face, we've got a 2 centimeters along each edge, right? So all of those are like 2 centimeters. It's kind of an equilateral triangle. And then the height of that triangular face is 1.7. So this red line right here is 1.7. Okay, so it's not quite as tall as it is wide. And then it says the container is 6 centimeters long. And so these rectangles are going to be 6 by 2s. Can you imagine that unfolding in your head? So we've labeled our diagram. That was step 1. And B now says to draw the net of this triangular prism on this grid. So I'm going to, if you remember how I kind of explained this, I like to imagine this shape sitting on my grid. So imagine the bottom of it here, the big base, is 2 by 6. So let's go ahead and find here in the center of this a 2. So there's a 2. And then let's do it 6 long. 1, 2, 3, 4, 5, 6. And yes, I do like to use my ruler. Makes me feel like I've got it going right. 1, 2, 3, 4, 5, 6. We'll do the same thing up here. Okay, and then we'll connect that. So there's the base. Okay, that's what it's sitting on. So this is a 2 by 6, and if you can imagine it sitting on that big base right there where I wrote that word, right? So then what's going to happen is then this right and left slanted sides are going to open up. Can you imagine that? And so what's going to happen then is we're going to have these other 2 rectangular faces kind of right here on the side. And they're going to match up with that other one, but they're going to be right beside of it. Okay, so there's our base, if you kind of want to label it, that's the base. And that's like the right side, and that's the left side. Imagine that unfolding. And then the only thing left are these two triangular ends. And I'm going to attach them right to the base. So you can imagine that triangle kind of folding down. And it comes up, it says 1.7. So not quite 2. So I'm going to draw that triangle face coming out just like this. Okay, and then we've got a matching one over here. So it's 1.7, and then I'm going to use my ruler to connect those up. Okay, and so this is what the net of that triangular prism looks like. So you can kind of see the base, and we just kind of unfolded the two sides, and then we folded down the two triangles. If you need to pause your video to go ahead and capture that, you can get it drawn. If yours is ready with mine, we're going to move on with question C. So C says, approximately how much plastic would it take to make this? And again, this is a surface area question. And so we're going to use our net to figure out our surface area. So if I'm looking at this, these rectangular prisms are each, if we find the area of each one, this is, we kind of do base times height. So this is 2 times 6. And so that rectangle is a 12. And these both match. So we know that they both have an area of 12. Okay. Our triangles, we have to do 1/2 times base times height. And so the 1/2 times, now the base, we knew that that was 2 centimeters. Remember, that was our picture. So times 2 times, and our height, this dash right up here, was 1.7. Okay, so we have to kind of use our formula, use our measurements. So 1/2 times 2 times 1.7. And if we do that, we should get 1.7 because half of 2 is 1, and 1 times 1.7 is 1.7. We can check that in our calculator just to be sure. So 0.5 times 2 times 1.7 equals 1.7. And so this is 1.7, and guess what? The matching one over here is also 1.7. Okay, so we now have all 5 of these faces, the area, and so to find the total, remember we add them up. So we have, and I'm just going to kind of write this up here, 12 plus 12 plus 12 plus 1.7 plus 1.7. That's what I'm going to add up in my calculator. So, and actually part of this I'll probably just do mental math. So 12 plus 12 plus 12, I know 12 times 3 is 36. And then we have 1.7 plus 1.7. But however makes sense for you to add that up, we're just going to add it. And then I get that that has a surface area of 39.4. And we measured in, was it meters or centimeters? I think it was centimeters. So centimeters squared. Remember, surface area is always squared because we're multiplying each of these centimeters times centimeters. Okay? And so there is the net of that shape. And then we calculated its surface area. We found the area of each face, and then we added them up. Okay, if you need to pause that to finish writing that down, make sure you show all of your work on this page. If you just have an answer, it is going to be incomplete. You've got to show your work and show how that drawing helped you to find it. Okay, so pause if you need to. If you're ready to go, we're going to flip on over to page 244. So we have one more shape here that we're going to do, and this one is a pyramid, and it's a square pyramid, I believe. So let's go ahead and read about this one. It says the Pyramid de Louvre in Paris is made of glass. The structure is above the entrance to the Louvre Museum. So the pyramid has no base. It looks like a square pyramid. So this is actually an opening, and they've got this big glass pyramid on top of their entrance, is what they're saying. So it says the base of each triangular face is about 36. So we're going to call this 36 meters. And it is a square, so that's going to be 36 meters, kind of all the way around there. And it says the height of each triangular face is 28 meters. So the height going up here is, and I'm just going to do a little thing, 28 meters. That's the height. Okay. So it says, first of all, label the pyramid diagram with our measurements. And we did that. We know that the base is 36 and the height is 28. We know enough to also do that square at the bottom because it would be 36 times 36. I'm not sure we're going to need that because it says that this pyramid has no base because of the way it sits at the museum. So let's go ahead with part B. It says on the grid below, draw a net to represent the pyramid de Louvre. Include the base on the net even though it is not made of glass. So we are going to draw it, okay? So now this one also has kind of a weird feature. It says one grid square is going to represent 4 meters by 4 meters. So they've showed you like instead of this being ones like we've done usually, this is going to represent fours. And the only reason we're doing that is so that we can actually fit this here. If we were to draw this 36 by 36, it really wouldn't fit on our grid. But if we let each of these little blocks represent 4 meters, then you can imagine, like if we divide this by 4, so 36 divided by 4, that's going to kind of be 9 squares. That one's going to be 9 squares. And 28 meters, if we divide that by 4, that's going to be 7 squares. So we're kind of going to like scale this. It's going to really still represent 36, but on our drawing, we're just going to draw 9 because each of these is going to represent 4. Hopefully that makes sense to you. It's a little bit of a scaled drawing. So using that, let's go ahead and draw this net. So our base is a square, and I want to start with that square right in the center. And it is 36 meters, but we figured out that we're going to do 9 squares by 9 squares to make it match with the scale of this grid. So as centered as you can, let's just pick a corner. Let's go for right there. And then I'm going to draw 9 squares over. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be the top of my square to get that base. And I always draw the base first. I've told you that a few times now, like draw the base and then imagine it unfolding. So it's 9 in that direction. It's also 9 in this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's get that on there. And now let's finish up that square. Okay. Okay. So there is our base. And it is 36 by 36, which on this grid is 9 by 9. Now, each of these is going to go have a triangle coming out from it, right? Because each of these 4 sides, if you can imagine that unfolding, is going to have a triangle. And it's going to be 7 squares tall. That was our based on this. So let's find the center. 1, 2, 3, 4, 5. I think the 5th one in is the middle. So kind of like right there's the center. And let's go up 1, 2, 3, 4, 5, 6, 7. And so that's going to represent our 28 meters in real life. But on this grid, it's only 7 squares. Okay. So can you imagine that? So we went up 1, 2, 3, 4, 5, 6, 7. And 7 times 4 would represent 28. And it's 9 squares, so I found the 5th square over to get the center. And we're going to repeat that on all 4 sides. 1, 2, 3, 4, 5. So there's the center, and then we're going to go out 7 squares. 1, 2, 3, 4, 5, 6, 7. I'm going to do all of those, then I'll draw them. 1, 2, 3, 4. There's the 5th one. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. There's the 5th one, and we'll go out 7. 1, 2, 3, 4, 5, 6, 7. Okay, so now I need to draw all of those triangles. And hopefully in your brain, you can kind of imagine these triangles folding up to form this glass pyramid at the Louvre. Have any of you been to the Louvre? I've never been to Paris, but I've seen pictures of it. It's kind of cool looking structure and entrance to the museum. I think you actually go down under it, like inside. All right, so there is my drawing. And so I have my base, which is 36 meters by 36 meters, right? It's a square. And then each of these triangles, the base is 36 and the height is 28 meters. Okay, I'm labeling it with the real measurements. We just had to draw it with that scale. Okay. All right, if you need to pause the video to finish your drawing, go ahead and do that. If you're ready to go, we're going to kind of keep on going, but make sure your drawing is finished before you keep going. Okay. So part C says, what is the area of each triangular face? Okay, so let's find that area of 1. And I'm just going to use the one that I kind of have labeled up here. So we know area of a triangle is 1/2 times base times height. So 1/2 times, and the base we know is 36. The height is 28. And I am definitely going to use my calculator for that calculation. So 0.5 times 36 times 28. And we get 504. And that's going to be meters squared. Okay. So we did 1/2 times the base times the height. And that is the area of one of those triangles. So we know each of these 4 triangles are the same. So this one's 504, this one's 504, and this one's 504. Okay, all of them are 504. So the last question says, how many square meters of glass was used to make the faces? So we're going to do 504, and I'm just going to times it by 4. We could add them up, but for this, I think it's just as easy to do 504 times 4. And we get that they would need 2,016 meters squared of glass to make that pyramid at the Louvre Museum. Okay? Hopefully that made sense to you. Today we practiced drawing nets and we practiced finding surface area. And remember, we didn't include the base on this because it is open at the Louvre Museum. It is not actually made of glass. It's just the four triangles. All right, so that's your journal work. And if you have those, you'll be ready to post those to Canvas. The last thing for today is a home link. And so if you go to your home links packet, you're going to find Homelink 5.7. And it is Homelink 5.7. And it's got like this little doghouse on it. Okay, so it's a rectangular prism. And it's got a little door cut out of it. Okay, so what you're going to be working on with this today is very similar to what we just did. You're going to be A, labeling the doghouse with measurements, B, drawing a grid to show the net of this doghouse, and then Sam, the kid, is going to be painting it, and so you're going to be calculating the surface area. So I'm going to leave that to you today to try on your own. It's really good practice of drawing the net based on measurements and then calculating that surface area. Okay, so post that in Canvas when you finish it, and good luck. If you have questions, you can always email me today, and I'll check in there. We'll review the answer to this tomorrow morning. All right, thanks.